We begin with a force versus position graph, and we ask what's the work associated with the interval from 1 centimeter to 2 centimeters, okay? X being the position, F being the force. The answer to the question is fairly straightforward. Work is equal to the product of force and displacement, or the product of average force and displacement when you have a variable force. So we approximate this first interval, but we could draw the, we can represent the first interval by a graph with 1 centimeter being the distance between 1 centimeter and 2 centimeters, and a curve representing the force. We can approximate that by a trapezoid. We just straighten out the curve. There's very little difference between the area, between the straight line segment and the curve. We estimate, based on the graph, that the altitude of the curve is about 1 centimeter. The average altitude is about 1 Newton, so that the average force is about 1 Newton. And then if we multiply the average force by the displacement, we get 1 Newton times 1 centimeter, which is 0.01 joules. A Newton times a meter being a joule, centimeter being a hundredth of a meter. And that was a simple calculation. Everybody pretty much got that. Okay, so that calculation, that average force of 1 Newton times 1 centimeter, corresponds to the calculation of the area beneath the curve for that 1 centimeter displacement. So the area under the curve is average force times delta x, which is the work done. Okay, the average altitude of this trapezoid, or of this region, is the average force, represents the average force. The width represents the delta x. We get the delta W. Okay, now we do the same calculation for the 3 subsequent intervals. And we got various results that were all in the right ballpark. The same calculation gave us something like 0.006 joules, 0.004, 0.003 joules. And of course, each work contribution corresponds to the work done between 2 positions. So from 1 centimeter to 2 centimeters, 0.01 joules, from 2 to 3 centimeters, 0.006 joules, etc. Again, everybody pretty much got that. Now, we then asked, what's the work done from the 1 centimeter position to each of these 5 positions, each of these 4 subsequent positions? From the 1 centimeter position to the 2 centimeter position, we've already calculated that as 0.01 joules. But from the 1 centimeter position to the 1 centimeter position, there's no work done. From 1 centimeter to 2 centimeters, 0.01 joules. From 1 centimeter to 3 centimeters, well, we have these 2 intervals intervening between 1 and 3 centimeters. We get all that work, 0.016 joules. From 1 to 4, we get the 0.020 joules, adding the 0.004 joules to the work done up to the 3 centimeter position. We get the work done up to the 4 centimeter position. Then adding the work done between the 4 and 5 centimeter position to the work done up to the 4 centimeter position, we get the 0.023 joules. And this results in a graph of the work done from the 1 centimeter position to the position X. Make a little arrow out of that. And we simply graph the work done versus the position X, and we get this graph, which we call a graph of the accumulated work, the amount of work accumulated from the 1 centimeter position to whatever position X. And of course, we could use this graph to estimate how much work is done, let's say, to the 2.5 centimeter. Here's 1, 2, 2.5 centimeter position. And we could project that over here, and we'd see maybe that's 0.013 or 0.014 joules of work. Okay, so we have this accumulated work graph. At any position X, it's the amount of work accumulated by this force between the 1 centimeter position and that position. So between 1 centimeter and 2.5 centimeters, we estimate from the graph 0.013 or 0.014 joules of work. And that, of course, would correspond to the area under this curve between here and here. If it's the 2.5 centimeter position, we'd get the area under the curve between 1 centimeter and 2.5 centimeters. And that area should correspond to an estimate we get from this graph. Now, next task was to find the average slope for each of these 1 centimeter intervals. And we'll go on with that in another clip.